Welcome to Snacks Weekly on Data Science. This podcast is all about making data science and machine learning knowledge accessible and less intimidating. Today, we are going to talk about metrics. This episode is based on a tech blog titled The Quest to Understand Metric Movements, written by the engineering team at Pinterest. You can find the blog link in this episode's description. Throughout this episode, we will explore this topic from both the business and data science angles. Now, let's dive in. On the business side, let's take a look at the problem to be solved. Pinterest is a visual discovery platform that helps hundreds of millions of users around the world find inspiration. From recipes and home decor to travel ideas and fashion trends. The platform serves billions of pins or ideas every single day across different countries, devices, and content types. Behind the scene, Pinterest monitors thousands of metrics, everything from view rates and engagement to latency, system performances, and the health of their data pipelines. When any one of these metrics change unexpectedly, let's say the click-through rate drops or latency spikes, it raises an immediate question: what happened? The tricky part here is that a metric movement could mean many different things. It might signal a code bug, an infrastructure issue, or a shift in user behavior. Sometimes, it could even be a false alarm caused by an upstream logging error or a sudden change in traffic patterns. For Pinterest, these unexplained movements can have real business consequences. Misdiagnosing a metric can lead team down to the wrong path, wasting engineering time or even hurting the user experience. So, understanding why a metric moved isn't just an analytical curiosity, it is also critical to maintaining product quality, the feature reliability, and the user's trust. That's what motivated Pinterest to build a system for rapid, data-driven root cause analysis. Now that we've understood the business problem, let's shift gear and dive into the technical side to see how the team tackled this challenge. In their blog, the Pinterest engineering team describes three complementary approaches that made up their root cause analysis platform. These are called slice and dice, general similarity, and experiment effect. Together, they help answer the million-dollar question: why did this metric move? Let's start with the first approach, slice and dice. This method takes a top-line metric and breaks it down into smaller, more detailed pieces along multiple dimensions. Think of it like peeling an onion. You start with the big picture, such as overall engagement rate, and then look at it by country, by device type, by content type, and so on. For example, imagine you see the video view rates have dropped. Slice and dice helps you identify where the drop is happening. Maybe it is concentrated on Android devices, or maybe it is more pronounced in a specific country or on a specific surface within the app. On the technical side, the system builds a hierarchy of segments, where each node represents a specific combination of dimensions. For instance, one segment could be United States, Android, video pins. For each of these segments, the system calculates how significant the change is compared to its parent segment, and how much it contributes to the overall movement. By ranking these segments based on their impact, the team can quickly pinpoint which slices of data are behaving abnormally. The tricky part here is choosing how to order these dimensions. some dimensions like country and regime have a natural hierarchy. Others, like device type or content category, are more orthogonal. The team had to experiment with different ordering strategies to make the exploration process intuitive and efficient. They also used OLAP-style queries to efficiently aggregate and compute the data across thousands of combinations. In short, Slice and Dice answered the question, where did this change happen? Now let's move on to the second approach, general similarity. In this method, the question shifts to when a metric moves, which other metrics move in a similar way. If two metrics rise or fall together, it might suggest they are related or influenced by the same underlying factor. To uncover these relationships, the team calculates similarity scores between pairs of time series metrics. They found that two measures work best for their use case. The first measure is Pearson correlation, which captures the strength of a linear relationship between two time series. The second metric is Spearman's rank correlation, which measures the strength of a monotonic relationship, even when it is not strictly linear, and can sometimes be more robust. At Pinterest, this root cause analysis functionality helps the team explore how performance metrics related to content distribution. For example, some types of pins are more expensive to render than others. So a natural question arises. If users suddenly see more expensive pins and fewer inexpensive ones, could that explain an increase in latency on the home feed or search feed? The similarity analysis provides the initial statistical signals that performance regressions and content shifts might indeed be connected. This motivates deeper investigations to estimate the exact causal effects. Of course, the team is careful to pinpoint that correlation isn't causation. Just because two metrics move together doesn't mean one causes the other. But these patterns offer powerful clues that help narrow the search for what's really going on. Finally, the third approach is experiment effect. This method taps into the company's extensive experimentation platform. The company is always running many experiments, testing new recommendation models, UI changes, ranking updates, and more. Because these experiments introduce intentional changes, they are incredibly valuable for identifying why a metric might have shifted. Here is how it works technically. A typical experiment uses A/B testing to measure the effect of a new feature. Users are randomly split into a control group and a treatment group, where the treatment group experiences the new feature. The experimenter then checks whether there is a statistically significant difference in key metrics, like user engagement, between the two groups. In this root cause analysis setting, the process is essentially reversed. Instead of asking, what effect did this experiment have? The system asks, given this metric, which experiments influenced it the most, whether intentionally or not. When someone requests a root cause analysis, they specify this metric, the segment, and the time window. The system then evaluates every ongoing experiment and computes each experiment's impact on that metric during that time frame. It uses statistical tests to estimate the effect size and then ranks the experiments by their impact. With this approach, if a metric suddenly drops, the system might tell you something like, Experiment A, which tested a new video preload feature on Android, had a significant effect on the metric. That provides an incredibly strong lead for diagnosing the issue. With all these three root cause analysis approaches working together, the team can form a complete picture of what's happening when a metric moves. Slice and dice reveals where the change happens. General similarity highlights what else changed at the same time. And experiment effects sheds light on what might have caused the change by design. By layering these insights, analysts and engineers can move from a broad mysterious something changed to a clear data-backed explanation. Now we discussed both the business problem and technical solution. Let's wrap it up. In this episode, we explored how Pinterest tackled one of the toughest challenges in large-scale analytics, understanding why metrics move. We looked at how their engineering team built a root cause analysis platform, combining slice and dice, general similarity, and experiment effects. Each of the approach solve a different part of the puzzle. Together, this system blends analytics, statistics, and engineering into a practical workflow that helps teams diagnose issues faster and with greater confidence. If you like the content of this episode, please subscribe to the channel. Give me a 5-star review and leave a comment. Your feedback is very appreciated, and I'll see you next week.